Hi there. Hope you have a fantastic day today. This lesson, I will teach you how to work out the magnitude and the directions of a resultant vector. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Let's say I have a vector. Let's say this vector here, vector v, let's say x and y. And then the directions of this vector here is angle theta. Now, please remember, directions of a vector is always start from positive x-axis and it goes anti-clockwise. Okay, keep that in mind. And where is true bearing, you start from north and we go clockwise. Okay, so do not mix up. So let's get into this. So the magnitude, let's say this is the magnitude of v. So let's say magnitude is r. Okay, the magnitude of v is r. So therefore, we can work out the I and j component in terms of cos and sine theta. So let's say this is vertical component here. So this is the y value. To work out y, we have opposite and hypotenuse. So that is sine. So we go sine of theta equal opposite. That is y over the magnitude. That is r. Then if I times r on both sides, so y is equal to r sine theta. Similarly, we can find the value of this, which is, let's say this x, of course. So we have adjacent hypotenuse, which is cos. So we go cos of theta equal x over the hypotenuse, that is the magnitude of v, that is r. And if I times r on both sides, so times by r, times this by r, so this cancel out. So this means that x is equal to r cos of theta. So therefore, v can be written as in column form or in coordinate form, doesn't matter. Let me just write in coordinate form. So is the x value first, r cos theta, and for y is r sine of theta. There you go. So we can also written like this is equal to r cos theta I plus the j component, that is r sine of theta j. So please keep this in mind for me, okay? So let's go through an example. First one. So we need to work out the resultant vector, that is the vector u and vector v acting on the particle p. So in another word, we need to add the two vectors together to find out the resultant vector, okay? So the resultant vector, first of all, is we know that is we need to work out vector u plus vector v, and we want to find the magnitude of it. So this is what we need to find. So before we do that, let's work out vector u and vector v first, okay? So we know that this angle here for vector u is 20 degrees. So therefore, the direction is always start from positive x-axis and we go anti-clockwise. So this is the directions of vector u. So that is 180 minus 20, so 160 degrees. So therefore, we can express vector u is equal to, so r cos theta, that is 30 cos of 160 degrees I, and for j component is 30 sine of 160 degrees j. So that is vector u. So to find vector v, so we know that vector v in here is already 10 degrees. So the direction for v is start from positive x-axis and it go anti-clockwise. So that's the answer. So the direction of this is 180 plus 10. So that is 190. Okay, keep that in mind. This is 190 degrees. So therefore, vector v will give me 40 cos of 190 I plus 40 sine of 190 degrees j. So now we just need to add these two vectors together to find the resultant vectors. So if we add them up, so that is vector u plus vector v, that will give me, so we just add the I components together and then we add the j component together. So if we add this up, so that is the I component and we just add this. So let me just write this down. So that will give me 30 cos of 160 degrees plus 40 cos of 190 degrees. Okay, and this is for I component. And then for j component, we add them up with this component here and with this. So let me just write this down. So that will give me 30 sine of 160 degrees. And then we add 40 sine of 190 degrees. And that's for j component. So now to find out the magnitude, so let me just put that in a calculator first, okay? Makes it easier, simpler, that's all. So I just go 30 cos of 160 degrees plus 40 cos of 190 degrees. So there you go. So negative 67.58. I just write in 2 decimal place, okay? That will do because I'm going to store this in memory A because I need that later. So I go answer, shift, store A. So negative 67.58. So equal negative 67.58 I component. And to work out J, so I just put in a calculator. So 30 sine of 160 degrees. And we add 40 sine of 190 degrees. So 3.31, okay? At 3.31 J. To work out this magnitude, so which is using Pythagoras theorem, okay? So U plus V magnitude, so which is U Pythagoras theorem. So 67.58 square plus 3.31 square. And square root, of course. That will give me, so I just go alpha A square plus alpha B square. And I square root that. So that gives me 67.66. Newton. Now to work out the direction, of course, we need to know which quadrant the resultant vector is. So let me just draw a diagram out. Just to represent where the vectors u plus v is. So we know that this is negative I component and positive j component. So it should be on the second quadrant because it's negative and positive. So negative for I component and positive. Okay, so keep that in mind. So this is the resultant vector. So let me just write this down. So this is negative 67.58. And this is 3.31. Okay. Now to work out the direction. So this is what we're after. Okay. So to work out these directions, let me just work out the reference angle first. And then we use 180 minus angle theta. That will give us the direction of the resultant vector. So to work out that, so we have opposite and adjacent. So I just work out the reference angle. Of course, I ignore the side. So that give me opposite, which is 3.31 over 67.58. That is theta is equal to 10 inverse of 3.31 over 67.58. So that will give me, and remember that I store I component in memory A and B is for the j component. So what I do, I just go alpha B divided by alpha A. Now, of course, I do not want the negative number, so I just times by -1 to get rid of negative first. Then I go inverse 10. So there you go. So I press the DMS button. So 2 degrees and 48 minutes. 2 degrees and 48 minutes. So therefore, the direction is 180 minus 2 degrees and 48 minutes. So that should give me, let's just go 180 minus the answer. So DMS, so that is 177 degrees and 12 minutes, okay? So 177 degrees, 12 minutes. That is the directions. So let me just write it down. So therefore, so there you go. Please pause the video and try this one yourself. Hi there, I'm back. How do you go? So let me go through it with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So first of all, we just need to work out vector u and vector v first, okay? And then we add them together. We know that the directions for vector u is this. So that is 40 degrees. So therefore, let me write this down. U is equal to 50 cos of 40 degrees plus 50 sine of 40 degrees. J, and this is I. And then for V, so this is 30 degrees. So therefore, all the way from here to here, so we have 360 minus 30. So that means 330. So that is the directions, 330 degrees. So therefore, vector V is equal to 70 newtons, okay, cos of 330 I components plus 70 sine of 330 for J component. So now we just need to add them up, okay? So to add them up, the I components, we just add them up together. So that will give me, so let me just write this down, U plus V is equal to, so we just go 50 cos of 40 plus 70 cos of 330 and I. And for J component, we just add the J component together. So that is this and this one here. So that will give me 50 sine of 40 plus 70 sine of 330. And that's J. So there you go. Then I just put that in a calculator just to make it easier. That's all, okay? So we go 50 cos of 40 plus 70 cos of 330. So that is 98.92. Let me store in memory A first. So that give me 98.92 I. Add, so 50 sine of 40, we add 70 sine of 330. So negative 2.86. So go answer, shift, store in B first. So negative 2.86. So I just clear this first. So minus 2.86 J. So there you go. Now to work out this magnitude, so I just write this down here. So magnitude of U plus V, which is using Pythagoras theorem. So I just go 98.92 square plus 2.86 square, and we square root of that. That is equal to, just go alpha A square plus alpha B square. because I and j component I store in A and B. Okay, keep that in mind. So square root the answer. So 98.97 newtons. Okay, so that is the magnitude of the resultant vector. So we need to find the directions. And we can see the direction is on the fourth quadrant because we have positive I component and we have negative j component. So let me just draw the vector diagram. So this is the resultant vector. So this is 98.92 and the vertical length is 2.86. Now we can just find the directions of this vector. So direction of this vector is from here to here. So we need to find angle theta first. And we go 360 minus that, okay? So tan of theta equal 2.86 divided by 98.92. So theta must be equal tan inverse of 2.86 over 98.92. So that will give me, so just go alpha b, that is the j component, divided by the I component. But then it's negative. I do not want negative, of course. It's just times by -1. I cancel it, okay? And I just write the reference angle. That's all. So inverse tan equal, and then press the DMS button. So 1 degree and 39 minutes. So 1 degrees and 39 minutes. So the direction is 360 degrees minus 1 degrees and 39 minutes will give me, so just go 360 minus the answer. So 358 degrees and 21 minutes. So therefore, the magnitude of the resultant vector is this, and the direction is this. So let me just write it out. There you go. I hope you got it correct. Thank you so much for watching. Bye.